Hello, and welcome to this Let's Talk Meshing webcast. Many of our users utilize Pointwise to assist them in completing experimental design or parametric trait studies. Others work in product development, where products may be evolutionary changes to an existing one. In each of these situations, users tend to have an interest in generating some set of configurations for analysis, where each configuration represents some variation to the shape of their analysis models in order to help identify trends, optimize a design's shape, or another related purpose. From the outset, it becomes quickly apparent that creating meshes for each of these configurations can be both costly and time-consuming, often to the point where the scope of these trait studies has to be reduced, or the number of configurations considered becomes limited. Aside from reducing the overall number of configurations being evaluated, automating the meshing process with glyph scripts, or resorting to the use of an overset meshing technique and solver, there are a few other strategies for meshing multiple related configurations more efficiently, which this webcast will explore. Repeatedly meshing entire configurations from scratch can often be intractable, so an emphasis has been placed here on demonstrating how to remesh only the localized regions of your analysis models that have changed from one permutation to the next. Doing so not only reduces the time necessary to mesh these configuration changes, but analysis results will more directly correspond to changes made to the analysis model itself rather than the differences in the global mesh. Incorporating this technique into your meshing workflow, together with project organization, mesh reuse, and Pointwise's grid merge capability, will make the task of generating meshes for each variation in your experimental design studies far easier, making you more productive overall. One thing I want to mention briefly before diving into some of the more detailed examples I prepared is that many users make use of parameterized CAD models. When I say parameterized CAD models, I'm referring to models that have been created in such a way that their surfaces can be reshaped by changing a set of user-defined parameters, changing the camber of a wing, for example. When you set up your CAD models using this approach, you can leverage Pointwise to take advantage of this in unique ways. For example, let's say I have exported a parametric CAD model and meshed this model in Pointwise, while providing unique names for all of the quilts that comprise it. I can usually reuse this mesh in its entirety with another perturbation of this model, where perhaps a few parameters have been modified. Pointwise will automatically snap the surface grid created using the original CAD representation to the new surface geometry so long as the number of underlying surfaces hasn't changed and the quilt names remain the same. Using this technique can help save users some time in situations where relatively small changes to surfaces of their models are being evaluated. One important tool in Pointwise that will be essential for parameterizing your meshes is the Layers feature. Effectively using layers will be invaluable to successfully organizing your projects, not just components of your CAD, but also the various parts of your mesh. Once you have organized your projects into layers, the Layers panel, together with selection masks, can be extremely useful when selecting specific entities of your mesh, as I'll demonstrate throughout this webcast. To highlight Pointwise's Layers feature and illustrate some of this webcast's other meshing strategies, I have created a project that consists of the geometry and mesh for the Drive Air model, a generic car model developed to facilitate aerodynamic investigations of passenger vehicles. The model is designed to be highly modular with exchangeable tops, underbodies, and other parts, allowing for up to 18 different configurations. The CAD data for the entire model is available in either IGES or STEP neutral CAD formats, and each component is provided in its own separate CAD file. Each part can be opened in Pointwise by using the built-in CAD import feature located under the File menu. This tool also works similarly for native CAD files created in professional CAD software packages such as CATIA, SOLIDWORKS, or PTC's Creo. CAD created in these and other proprietary CAD tools can be read directly into Pointwise using the built-in native CAD reader without having to resort to a neutral intermediary format such as IGES, STEP, or VRML. This avoids any potential issues that may arise due to CAD translation between native and neutral formats. As each part is brought into Pointwise, you can move it to its own layer. Simply select the geometry in either the display window or list panel, and in the Layers panel enter an integer corresponding to the desired destination layer in the target layer number entry field. The selected geometry entities are then moved to that layer. In the table below the layer assignment entry field, you can see a list of all of the layers with something in them. You can also show all of the available layers, including those that are empty, by toggling the Show Empty Layers checkbox below. A descriptive label to help you easily identify what is contained in each layer can be specified using the available description entry field. There are other entry fields that provide you with the ability to filter the list of layers for more complex models to match any number of user-defined criteria. You can switch the active layer, that is the layer in which newly created entities are stored, whether they are geometry or grid related, by double-clicking on the layer in the table or selecting it and clicking the Set Current button below. A yellow chevron in the Layers table indicates the active layer. Entities that exist in other layers can be toggled either on or off, in addition to those entities of the active layer, by clicking the checkbox next to each one. There are also dedicated buttons below that provide similar capabilities for quickly showing or hiding multiple layers with a single click. Because this dry layer model is highly configurable, it makes sense to put each part into its own layer. Then each part can be meshed separately in another layer to be combined later with other parts in whatever combination is desired. This is exactly what I've done here. Starting with the vehicle's body, the model, or a collection of rational B-spline CAD surfaces, is isolated in one layer, and then I placed the quilts in a separate layer where I could assemble them appropriately. You can quickly select a model's quilts by opening the Mask panel located under the Select menu in Pointwise. In the Database section, toggle on quilts before exiting the panel. Then simply select everything in the display window. The selection mask limits selection to only those quilts that are actively displayed. Then it's just a matter of relocating those quilts to their own layer. Turning on shading for the quilts, applying rainbow colors, and showing only quilt boundaries are helpful tools to help expedite quilt assembly. Once the quilts have been isolated, then the surface mesh for the car body can be created in another empty layer with visibility of the model toggled on. In this manner, surface meshes for the car body, estate back, fastback, notchback, smooth underbody, detailed underbody, mirrors, and wheels have been created, and I then have the ability to toggle on any combination of these parts as needed using the Layers panel in Pointwise. Being able to reuse parts of a mesh is an important strategy to keep in mind as you're working through your projects. Thankfully, the copy, paste, and transform tools Pointwise offers makes reusing these meshed parts as simple as copying and pasting text in your favorite word processing software. As an example of this, I'll use a single wheel, which I have already meshed, to reproduce grids for the remaining 3 wheels in the set. Rather than expend a lot more time reproducing meshes on the other wheels, You can select the existing wheel mesh using the Display Window or Layers panel, copy it using the common keyboard shortcut with which most users are already familiar, or via the Edit menu, and then paste it, again using either keyboard shortcut or applicable Edit menu item. Pointwise then prompts you to transform the copied selection in some way, because if the copied grid entities were pasted in place, the copied elements would be automatically merged, leaving you with just the original mesh. For this first copy operation, I simply want to translate the copied grid entities in the x-coordinate direction, so I'll select the appropriate transformation from the list. This opens the Translate panel, where I can input the translation vector and see a preview of where the grid entities will appear in the display window once the transformation is complete. Click OK to save and exit the Translate panel. Click OK once again to paste the grid entities at the specified location. Now I have my second wheel. Adding the remaining two is accomplished in pretty much the same manner. In this second case, I'll select the Wheels layer and then use the Add to Selection button to demonstrate its utility in selecting both wheels at the same time once a project has been organized into layers. Again, copy both wheels, paste, and in this time, choose the mirror transformation. Mirror the wheels about a constant y equals 0 plane by clicking the corresponding radio button. Click OK to save and exit the mirror panel, and then click OK once again to paste the copied entities. In a few minutes, I've generated meshes for all four wheels, rather than expending time meshing each one individually. Having the meshed parts I wanted to reuse isolated in their own layer was extremely useful in expediting this task. Sometimes there are situations where you want to add a component or part to your mesh. As an example, you may be interested in the drive increment due to the addition of mirrors to this drive air model. To do this, you would need one mesh for the reference vehicle without mirrors and another that includes them. Is it really necessary to mesh the entire car for both cases in order to add something so small? Let me show you how you can avoid that pain using Pointwise's Auto Merge tool. As before, I have the car's body already meshed and in its own layer. I also have the mirrors meshed and in a layer of their own as well. I will make the mirrors my active layer and toggle on the mesh for the car's body. The mirrors aren't exactly positioned where they need to be, so first I'll select the connectors and domains comprising a mirror, and from the Edit menu choose the Translate option from the Transform submenu. This opens the Translate panel, where as before I can enter a translation vector, this time using the display window. Click OK to save the transformation and exit the Translate panel. Now the mirror is situated correctly, but it isn't integrated with the mesh of the car body. The nodes, connectors, and domains of each part overlap one another. To resolve this, I can use the Auto Merge capability within Pointwise's Merge panel. This panel can be accessed from the Grid menu. In this case, I first want to merge the extra nodes associated with the mirror onto the connectors along the car's body. To do so, I'll begin with the Merge Pairs of Entities frame starting with the Node Connector Radio button option. Entering the appropriate tolerance in the Tolerance entry field at top will highlight nodes and connectors that match in the display window and list them in the table below. By selecting them and clicking Apply, these nodes associated with the mirror are merged with the connectors along the car body. Next, I want to merge the connectors of both mirror and car body, so I'll switch to the Connector Radio button option. By entering an appropriate tolerance and selecting the pairs of connectors from either the list in the table or from the display window, the pairs of connectors are merged together after clicking Apply. the last step requires redefining the domain for the car's window. To accomplish this, first select the domain and from the Edit menu, select the Add Remove Edges option. In this panel, it's probably easiest to restart the domain and redefine its edges. Click the corresponding button and then trace the edges for the new domain. Click OK to save the domain and exit the Add Remove Edges panel. Now the mirror has been integrated with the rest of the vehicle's body. While this demonstrates how you can merge surface mesh parts together quickly in Pointwise, I would still need to create new volume meshes for both configurations, a volume mesh for the clean reference body and another for the configuration with mirrors. Doing so, however, will introduce extensive differences in the global mesh between the two configurations, and it would then be more difficult to attribute the changes in drag due to the addition of the mirrors and not as a result of global changes between each mesh. Therefore, we need a way to parameterize the mesh so that only the localized regions in the volume are affected by changes to the underlying configuration. Let me demonstrate how this can be accomplished within Pointwise. The drive air model includes 3 different tops: an estate vac, a fast vac, and a notch vac. In my Pointwise project, I have used 3 separate blocks to define the overall topology. The first block consists of the top itself. The second block is a mesh refinement block after the vehicle. And the third block includes all of the off-body mesh, excluding the aforementioned regions around the car's top and the wake refinement. If you look at a constant Y plane cut through this last block of the mesh, you can see the regions which have been excluded topologically. And now, look at the same cut through the mesh in which the other 2 blocks have been added in. Here I am showing a block which contains the volume mesh specifically created for the fastback. It's in a layer of its own, so I can toggle it on and off as necessary to swap with one of the other available tops. I've done the same thing for the estate vac. Both tops are point matched with the car's body and the rest of the volume grid. All 3 surface meshes for each of the 3 tops and the car's body share the same set of connectors along their shared interface. If I need a mesh configuration that uses either of these parts, they're just a click away in Pointwise. Simply select each block and export the mesh and boundary conditions. Each grid is exactly the same between configurations except for the small, localized changes in the mesh due to the specific component that has changed. There's still the notchback remaining, so let me demonstrate how to create another block using it. First, switch to a new active empty layer and label it notchback block. Next, toggle on both the off-body mesh, which includes the volume grid for the parts that are unchanging, and the surface mesh for the notchback top. Then simply select the domains and using either the keyboard or toolbar shortcuts, create the block. Again, using the Add to Selection button helps easily select all of the domains for the notchback surface with a single click, rather than having to select each domain individually, orient the view just right to get a view suitable for box selection, or iterate over a turning angle to find one that allows bulk selection of the desired entities. Sorting your parts and their entities into layers at the outset of your project usually pays back dividends over the life of a project in time it saves selecting entities alone. If everything is successful, then a confirmation appears in the messages window and a new block appears in my newly created layer. I have already set some defaults for new T-Rex blocks using the Defaults panel prior to setting up and initializing the other two blocks for the EstateBack and FastBack tabs. This ensures that when I go to initialize new blocks in the T-Rex panel, that the settings used are consistent between blocks. This also helps save a little time by not having to repeatedly enter these settings for each new block that is created. Select this block and open the T-Rex panel from the Edit menu. Note that the same settings I provided as defaults are already set in this panel for me. I just need to set the boundary conditions for the anisotropic extrusion. After switching over to the Boundary Conditions tab, select the notchback domains and set them to a wall-type boundary condition with an initial cell height for the extrusion. Then the two interface domains need to be set as match boundary conditions. This ensures that as the anisotropic tetrahedral extrusion front marches along, it matches the existing cell spacing that already exists on these domains. The other domains for this block can remain unset. Finally, the block can be initialized by switching over to the Solve tab and clicking the corresponding button. After the volume mesh is created, the quality of the resulting mesh can be surveyed before saving the block in the Examine panel. And that's all there is to parameterizing your meshes to quickly accommodate configuration changes, which should help minimize your meshing efforts. You can probably imagine incorporating another localized volume grid surrounding the mirror, such that your parameterized mesh would also allow you to toggle the mirrors on and off as needed. Another configuration might allow you to toggle between the smooth and detailed underbody parts. This brings us to the end of this webcast. Thanks to everyone for joining us today. If you have any questions about this webcast, then please don't hesitate to post your questions to the YouTube comments section below, or send your questions to us at letstalk@pointwise.com. You can also tweet your questions to Pointwise using the Let's Talk Meshing hashtag.